Hello students, welcome to Vidhai, and this is Exam Vidhai video. Exam Vidhai is a non-profitable initiative by the student of IIITDM Kancheepuram to give free coaching and resources to the student preparing for the national level exams like NTSE and NMMS. And I am the volunteer of the Vidhai, and I am here to teach you the topic matter around us. So let's move on the content of this video. So the content of this video is what is matter, building block of matter, naming elements, classification of elements, compound and its classification. So let's start with what is matter. A student, you see in your daily life that various things around you, all those things are considered as matter. So how can we say that this thing is matter? Anything which having mass and occupies some space is considered as a matter. For example, if you take your pencil box, it has some mass, and if you put it on your table, then it will occupy some space also. So that your pencil box is also a matter. These matter are exist in is composed of smaller particles such as atom, molecule, and ions, which we will discuss later. Matter exists in three forms, that is solid, liquid, and gases. And here are the some examples for solid, that is wood, stone, sand, iron, and for liquid it is like water, milk, fruit juice. Gases like oxygen, nitrogen, carbon dioxide, all these are you know already. These are the some pictures in all three different states of the matter. So building block of the matter. What is the building block? The smallest thing which is used to make anything is known as building block of that substance. So as you know, brick is used to make your houses. Like that only, atom is the building block of the matter. Means the smallest unit which is used to make a matter is atom. And as we discussed earlier, that a matter is composed of either atom, molecule, or ion. So, what is atom? So, the smallest particle of an element which exhibits all the property of element is known as atom, and it may or may not be exist independently. What is the molecule? Atom of same element or different element to combine to form a molecule, and these molecules are exist independently. And ion, it is a group of atom which is having charge on it, so that is called ion. So here you can see this is an atom which consists of electron, proton, and neutron. This electron is negatively charged and this proton is positively charged, and neutron is neutral in nature, which is found in the nucleus of an atom, which you will study later. Here you can see these are the ions because they are having some charge on it, either positive or either negative. For sodium it is positively charged, and for chlorine it is negatively charged, so they are known as sodium ion or chlorine ion. Now there are lots of elements exist in this world, in universe. So how you can remember all these elements? It is very difficult to learn all these elements. So there are a simple representation of these elements by using symbol. But in earlier stages, only four elements are got the symbol to denote. Like what are these basic elements? Like for earth, air, fire, and water. The Greek symbol air is represented, how fire, earth, and water is representative. So there is two, like for air and fire it is masculine, and earth and water is feminine. It is considered like this. After that, alchemist symbol came into picture, in which the different metal that they are used were represented by the above mentioned symbol, while they try to change less valuable metal into gold. And this process of transformation from metal to gold is known as alchemy, and the man who did this work is known as alchemist. So here is the pictorial symbol of some element which is used through the alchemist symbol. Then in 1888, the Dalton symbol comes on the basis of name John Dalton, who is an English scientist who tried to give different symbol to the elements. Like for hydrogen, the symbol is provided for nitrogen. So some pictorial symbols are given to each element to represent that element. Then in 1830, Brazilian symbol came, which is used on the named on the scientist name, that is Jacob Brazilius, who used alphabet rather than the symbol or sign. So we will see how this presentation is done. So for naming the element, there are few rules we have to follow. So first is for non-metals, what we use just the first letter of the element. Like if it is boron, for its symbol we use B. For carbon, we use C. For fluorine, we use F. And for hydrogen, we will use H. Like that, we will give symbol to each element which are non-metals. Second, if two elements having the same first letter, then what we will do? Then what we will do, we can simply go for the second letter and we will use second letter for the different element. Like for barium and beryllium, you can see B is common first letter, but A and E are different. So for as a symbol, we will use Ba for barium and Be for beryllium. For bismuth and bromium also you can see like Bi and Br. So we use Bi and Br as a symbol for bismuth and bromine respectively. But what you have to remember that the first letter should be in capital letter and the second letter should be in lowercase. Then third rule is like, what if the first two letter of the element is same? Then simply we will go for the third letter. So if first two letter of the name of element are same, then the symbol consists of first letter, second letter, or either third letter, which is not common in both. So if you see the example here, that organ and arsenic, or in organ AR and in arsenic AR is common, but for here like third letter is different, that is S and G. So for organ we use AR, but we can't use AR for arsenic, so we will go for the third letter, that is S. So we will use AS as a symbol for arsenic. Like that also there are different example you can see here. Moving to next rule, like some element has given symbol by their Latin name. So various elements have their Latin names, just like copper have cryptorum, Silver is argentum. So by using this Latin name, we will give symbol to these elements like Cu, Ag, Au, Hg for mercury, lead, plumbum for Pb, like that. Tin, steno, so Sn, like that. We will use symbols for these elements by using their Latin name. And some elements are given name by on the basis of the country, scientist, color, mythological character, or any planet. Like American, so AN is given, the name is derived from a country name that is America. That European, EU, that is country name Europe, Nobelium, and no, it is a scientist name Alfred Nobel. We will give symbol and no like that only. Here are some planet name like plutonium, neptunium, uranium, which is derived from the planet name Pluto, Neptune, and Uranus. So how you will write the symbol of an element? So you have to consider two things. If there is only one letter for the symbol, then it should be in the uppercase, that is in capital letter. And if there are two letter in the symbol, then first letter should be capital letter and the second letter should be a small letter. Now we will see what are the classification of elements. So elements are classified into three parts, that is metal, non-metal, and metalloids. These are some pictures of metal, non-metal, and metalloids. So firstly we will go through the metals. You got some metal name like iron, copper, silver. All these are metal. But the question arises, how will we get to know that it is a metal, non-metal, metalloid? So there are some physical and mechanical property exhibited by these metals so that we can classify them into different, like whether it is metal, non-metal, or metalloid. So we will go through these properties. So if we're talking about the physical state, metals are always solid in the normal condition of temperature and pressure. But there is an exception, that is mercury, which is liquid at room temperature. And the elements like cesium, rubidium, francium, gallium become liquid at or just above the room temperature. Then second property is hardness. So metal are very hard that they can't be break easily. But there is an exception in that this also, like sodium and potassium are very soft in nature, like that it can easily cut by the knife. Osmium is very hard that can stretch the glass for scratching. So it is used for scratching purpose. Then luster, that shiny nature of any substance. So as you know that gold, silver, these are all metal and they shine also. So this is a property of metal that they can shine. They have some luster. But uh, calcium is an exception here. In density, metal are very dense in nature. That is, they have more weight. But potassium and sodium, as they are very soft in nature, so they have very low density. The melting and boiling point of metal is very high, but the melting point of sodium, potassium, mercury, gallium are very low. So that are the except, exception in the melting point of the metal. Then sixth property is tensile strength. If we like, if we give some, like if we stretch anything, if it will break easily. That means it has very low strength. But metal, you can see, if you want to break a iron rod, if you want to break a iron rod, but you can't easily break it. So this means that they have very high tensile strength. So this property is called tensile strength. But some exception are there, that is zinc, arsenic, and antimony are having very less tensile strength. Then seventh is malleability. Malleability is a property in which you can transfer a substance into thin sheets. You see some sheets like aluminum sheet and iron sheet. So these are metal and then they can be hammered and turned into a thin sheet. Ductility. Ductility. Ductility is a property in which you can transform a metal into a wire. So you see copper wire, aluminum wire, like that. So metal can be drawn into wire. Conductivity. Conductivity. So metal are very good conductor of heat and electricity. As aluminum is used in your home for the cooking purpose, so it is a very good conductor of heat. But some exception are there, like bismuth and tungsten are the poor conductor. Tenth property is sonorous. Sonorous means if you hit that metal with hardly, then it should make sound. If you beat some, like if you take iron and if you beat it, then it will obviously make some sound. So metal produces a typical sound whenever it got beaten or hit it hardly. So what is non-metal? We will see. So elements that do not generally shine, neither too much hard, not too much soft, are considered as non-metal. And all gases which exist in the universe are non-metal. Some non-metal are like sulfur, carbon, and oxygen. The physical state, if we are talking about, then metal occur in all phases. Non-metals are occur in all phases. Solid, liquid, and gases at the normal temperature. For example, sulfur and phosphorus occur in the solid state. Bromine is occurring in liquid state, and oxygen and nitrogen is occurring in gaseous state. So non-metal exists in all the three forms. But metal usually, what we study, metal usually occurs in solid state with having some exception. And talking about hardness of non-metal, it is very less hard. But there is an exception, that is diamond, which is very hard in nature, that much hard that it can scratch or scratch a surface. Luster and non-metal are usually non-lustrous in nature, and but exception is diamond, because diamond shines very much. And if you're talking about density, it is having very low density, but except diamond, because diamond is heavy in weight. Melting and boiling point. The non-metal are having very low melting and boiling point, but the carbon, silicon, and boron are some exception because they have high melting point as expected from the non-metals. Now talking about tensile strength, they don't have very much tensile strength, but carbon fiber is tensile as steel. Steel, which is a metal, so it has obviously a high tensile strength. But carbon here, being a non-metal, is also having the tensile strength same as the steel. So this is an exception. Malleability. So non-metal are, as they are brittle in nature. Brittle means if you try to transform it into either sheet or wire, and then it can break easily. They can't be transformed or molded. So they are brittle in nature. So non-metals are non-malleable and also non-ductile. They they can't be transformed into wire, nor it can transform into a sheet. But carbon fiber is highly ductile, so it is an exception. Now, talking about conductivity, though, so non-metal are very bad conductor of electricity as well as heat. But graphite is an exception here, and they are non-sonorous in nature. These are some examples. Now we will go for the comparative study of metal and non-metal. On the basis of different properties, we will see how they are different from each other. For physical state at the room temperature, we will see like metal are usually solid in nature, but some exception only like mercury and what we studied some mm, other element which exist at the room temperature in liquid form, but non-metal exist in all three different states like solid, liquid, and gas. And malleability, they are good malleable, but non-metal they are brittle in nature, so they didn't malleable that much. And ductility, they can easily transform into wire, but non-metal can't be transformed into wire that much easy because they are brittle in nature. They will break if we want to transform it into wire. The melting point, it has very high melting point, but non-metal has low melting point. Boiling point also, that, that has, it has high and it has low density. They are usually high density and they have very low density for non-metal. And conductivity, if we are talking about, then it is a good conductor of thermal and electrical conductivity, but non-metal are very poor conductor of conductive, poor conductor of heat and electricity. Now we will go for some application and uses of this metal and non-metal. So firstly we will go for metals. So iron, which is a metal, it is used for making bridges, engine part, iron, steel and bar. The steel bar, iron bar, which is used, iron rods, which is used in your home for making your homes and something like that. It is a iron rod. Then copper is used for making electrical wire, coin and statue. The older coins which you see, you might have been seeing these coins. It is made up of copper. You can see this. This is a copper coin. Silver and gold. This is very common. You all know that it is made used to make jewelry in decorative purpose and also for photography. Then fourth is mercury. So it is used in thermometer and barometer because it is very high density and uniform expansion at a different temperature. So it is highly dense, and if it got temperature variation, it will rise. That is why it is used in the thermometer for measuring the fever. Aluminium. This is, you can see, an aluminum wire which is commonly used in your home, and some it is also used in aerospace industry. Why? Because aluminum is very light in nature, so making aircrafts it is used. Like the lead, which is used in automobile batteries and X-ray machines. Now we will see the example application of the non-metals. So diamond, which is a form of carbon, it is used for making jewels. Or as I told you earlier, that diamond is very hard, so it is used for cutting and grinding purpose also. Graphite, which is also a form of carbon, is used in your pencil lead. That you know very well, that is the lead is made up of graphite. Second is sulfur, which is used for manufacturing of gunpowder and the vulcanization of rubber. Then third is phosphorus, which is used for matches and rat poisons. Thing of ammonia, chlorine, which is used for bleaching agent and sterilizing the water. Sterilizing means for purification of water. The bleaching powder is used that is made from the chlorine. Now, hydrogen is used as a rocket fuel. Hydrogen flame is used for cutting and building purpose as well as a reducing agent. This is all about the application of the metal and non-metal. Now we will go through the metalloid. What are metalloid? So some elements have some property of metal and also as well as they have exhibit some property of non-metal at the same time. So such element is known as metalloid. Here are some example of metalloid like boron, silicon, arsenic, germanium, antimony, tellurium, polonium. These are the example of metalloids. So metalloids are solid at room temperature. They can form alloy with other metals. If they react with other metal, then it will form a alloy. Third, some metalloids such as silicon, germanium can use an electrical conductor under a specific condition, so they are known as semiconductor. As they are not pure metal, so that is why, and but they conduct electricity. That is why they are known as semiconductor. And silicon is an example which is luxurious in nature, but it can't be malleable and ductile. It is brittle. So you can see brittle is a characteristic of non-metal, but lustrous is a characteristic of metal. That is why silicon is a metalloid because it exhibits both property of metal and the non-metal. Now, what is the uses of metalloid? We will see. So, silicon is used in electronic device as a semiconductor, and boron is used in firework and as a fuel for ignition in rocket. Now, we will go through the compounds. So, what is a compound? Compound is a pure substance which is formed due to chemical combination of two elements, two or more elements in a fixed ratio, either by volume or by mass. So, if we take an example, that water is a molecule. Why? Because it is composed by two atoms, two elements, that is oxygen and hydrogen, but there is a specific ratio by mass in which they are combined to form water. Like oxygen is ratio is 1 and hydrogen ratio is 2. Like if one oxygen is there should be two hydrogen atoms, then it will combine to form a molecule of water. There are two types of compound: inorganic compound and organic compound. Those compound which is obtained from non-living sources like rock, mineral are known as inorganic compound. Example: chalk, baking powder. And the organic compound which is obtained from the living source is known as it is organic compound like protein, carbohydrate, etc. Now, compound in solid, like some compound that exist in the solid state. We will see what are those solid compound and their constituent elements. So silica, sand, it is composed of silicon and oxygen. Potassium hydroxide, whose chemical name is caustic potash, is made up of potassium, hydrogen, and oxygen. Sodium hydroxide, that is caustic soda, it is constituted of sodium, oxygen, and hydrogen. Copper sulfate, it is made up of by the composition of copper, sulfur, and oxygen. And zinc carbonate, which is also known as calamine, is a composition of zinc, carbon, and oxygen. Some liquid compound is also exist in the universe, that is which a few like water. That is, I already told you, that is it is a composition of hydrogen and oxygen. Hydrochloric acid, and constituent element is hydrogen and chlorine. Nitric acid is hydrogen, nitrogen and oxygen. Sulfuric acid, hydrogen, sulfur and oxygen are constituent element for sulfuric acid. And vinegar, uh, which is also known as acetic acid, its composition is carbon, hydrogen and oxygen. And some gaseous compound which exist, that is carbon dioxide and carbon monoxide. It is composed of carbon and oxygen, sulfur dioxide, sulfur and oxygen, methane, that is CH4, so carbon and hydrogen, nitrogen dioxide, nitrogen and oxygen, and ammonia, NH4, that is nitrogen and hydrogen are the constituent element for ammonia. Now, use of compound. So, in daily life, we will use some compounds. So, we will go through it. What compound we will use for our daily purpose. So, water. That is the chemical name of water is hydrogen oxide. And what is its constituent? It's hydrogen and oxygen. And what is its use? We will use it as drinking purpose and as a solvent. Solvent, you know, which can dissolve everything in it. Then salt, what you use. Its chemical name is sodium chloride. It constituent are sodium and chlorine, and it is a very essential component of our daily life, and it is also used for preservative, as in in pickle, meat, fish. We will use salt so that it can't get spoiled that much early. Sugar, what we use. Then sucrose is the chemical name for sugar, and its constituent is carbon, hydrogen, and oxygen. And it is used for preparing sweet, toffees, and the fruit juice. Then baking soda, chemical name is sodium bicarbonate. Its constituent is sodium, hydrogen, carbon, oxygen. It is used as a fire extinguisher, preparation of baking powder, and the preparation of cakes and bread. So, if you want to make a cake or bread in your home, what you want a baking soda. And washing soda, sodium carbonate is its chemical name, and its constituent is sodium, carbon, and oxygen. It is used as a cleaning agent in soap. In soap, washing soda is there, which is a cleaning agent, and it is also used for softening of hard water. Then bleaching powder, its chemical name is calcium oxychloride. Its constituent is calcium, oxygen, and chlorine, and it is used as a bleaching agent just for purification of drinking water. Quicklime, that is calcium oxide. So calcium and oxygen is its constituent, and it is used for manufacturing of cement and glass. And slag lime, that is calcium hydroxide, is its chemical name. Chemical calcium, oxygen, and hydrogen is its constituent, and it is used for whitewashing of the wall. Then lime soda, that is calcium carbonate. Calcium, carbon, and oxygen are its constituent, and it is used for preparation of the chalk pieces. So these are some common compounds which we use in our daily life, and we will go through the chemical name of these compounds, and we see what constituent is used to make this compound, and we go through the uses of all this compound in detail. So thank you student for attending this class.